Hello and welcome. In this second part of the tutorial, we will visualize the TROPOMI product that we downloaded in part 1. There are many tools we can use to visualize TROPOMI data. These include QGIS, we have ArcMap, Snap, that is the Sentinel application platform software, and we also have Panoply. QGIS, Snap, and Panoply are open and free softwares which are available to everyone. In this tutorial, we will focus on QGIS and Snap. To download the latest version of QGIS, just go to qgis.org. For Snap and Panoply, we just Google Snap download or Panoply download. You will find the right ESA and NASA sites where you can download the latest version of these softwares. To start our visualization, we will use QGIS. So first thing, you open your QGIS and then set your base map. Essentially, this will act as a reference to know if our product correctly aligns with our area of interest. To do this, we go to Web, Quick Map Services, select OSM and OSM Standard. We also have to make sure that our coordinate reference system is set to WGS 84. Okay. At this point, it's also important to note that Quick Map Services is a plugin that needs to be installed beforehand. Let's load our product. To do this, we go to Data Source Manager, select raster, and browse to where the product is. This is the product that we downloaded. Select it and click Open. Then we click Add. What happens is that we get a drop-down box with several layers, and this is the beauty of NetCDF files. It carries a lot of information with a lot of variables. The variable that we are interested in is the product nitrogen dioxide tropospheric column. We select it and click OK. You can see here that it is added to our layers. We click Close. Normally, during the addition of this layer, it asks for the correct coordinate reference system that we want to use. This time it didn't, and that's why there's a question mark that appears here. So to set the correct coordinate reference system, simply click on the question mark and select the coordinate reference system of interest. In this case, it is WGS 84, and click OK. Remember, the product that we downloaded was one that was covering Ecuador, and as you can see, this product is not aligned with this area. So to know exactly where our product is, we right-click on the layer and select Zoom to Layer. As you can see, our product doesn't align well. Indeed, it is out of scope. Looking at the product properties, we will understand why. So we right-click again on this layer, go to Properties, and we see that the product extent is from -0.5 all the way to 4172.5 degrees, and this kind of extent does not exist. This is one of the shortcomings of using QGIS to visualize scientific data. For this reason, we need corrections. To make corrections, we will use SNAP, that is the Sentinel application software. So we open our SNAP software, and SNAP software has three main windows. The Product Explorer window, where we are going to get information about our file or product. We also have a window here where we can carry out several tasks. For example, we can change the color of our product, or we can be able to zoom in and out and look at our product in details using the navigation button or tab. We also have the main product window here. So let us load our product. To load our product, you can simply go to File and Open Product, or you can use the shortcut Open Product and browse to the location where your product is stored. In this case, we have our product here, and then we click Open. Our product will be loaded on the Product Explorer window. When we explore more about our product, we will see that it has a lot of information coming with it, as we already saw on the QGIS file, on the QGIS window. Here we can clearly see that we have metadata, that is information about our data, index codings, flag codings, vector data, and the bands. And this is exactly where we have our variables that we are interested in. So to load the variable that we are interested in this case, nitrogen dioxide tropospheric column, you can just simply double click on it or right click on it and select Open Image Window. What happens is that our product will be loaded in the main window. If I hover on my product, you will see that the latitude and longitude values down here do not change. So that means that the correct latitude and longitude values coordinate have not been pinned on this product. To do so, we will go to Tools, Attach Pixel Geocoding, and for the longitude band, we will select Longitude Product, as it has already come. And for the latitude band, we will select Latitude Product, as it has already automatically selected. We click OK. This is a process that takes time, so please be patient. Okay. Since our latitude and longitude has been attached, you see that when I hover over my product, it gives the correct values here. I hover and you can see that the latitude and longitude values have been set. To make these changes permanent, I will go to File and export my product. Click on Export, and I will select NetCDF CF format. And then I will give it the correct or an appropriate name that I will be able to remember. I will just So our product has been exported. What we do is load the product that we have exported. So we will first remove our original product and then load the exported product using the procedure we already saw. This is our product. We go to Bonds and select nitrogen tropospheric column product and load it. Indeed, when we hover again, we can be able to see that the latitude and longitude values are still attached to it. Now let us provide the correct projection. To do this, we go to Raster, and then we go to Geometric Operations and select Reprojection. Here we have a box with input and output parameters and the reprojection parameters. Let's start with the input and output parameters. Our source product is going to be the exported product. So we browse to where the product is located. We select it. And then we give our product the correct or an appropriate name. In this case, it has referred to itself as reprojected. I will leave it like that. We also have to make sure that we save it in the correct format. And the format that we are going to use or we are using in this case for our data is NetCDF CF. I will also make sure that it is in the correct location where I want it to be. And that is correct. Next, the reprojection parameters. Here you can choose the coordinate reference system that you would like or you are using. Maybe you have a custom CRS, you can be able to use that. If not, you can use one of the predefined, which I am using, and this is WGS84, and that is the coordinate reference system that I had already set on my QGIS, and this is what I will use. The rest remains the same, and then I click Run. This is also a process that takes time, so please be patient. Our product has successfully been reprojected, so we click OK, close. And when we look at the Product Explorer window, we can also see that it has been loaded. So I will remove the exported product so we can just focus on the exported and reprojected product. As you can see, it looks totally different from the way it was before. So this shows us that our product has been corrected. That is it has the correct extent, that is the longitude and latitude values have been attached, and it also has the correct projection. In part 3 of this tutorial, we will look at how to visualize and analyze this corrected product in QGIS.